In this video, we'll be talking about switches, what they are, how we describe switches, and what our options for switches are in every circuit in falstad. All right, so what is an electrical switch? Well, we all know what a switch is because we've used them our entire lives, but how do we formally define this? Well, that's any device that can interrupt the flow of electricity through a circuit. This includes switches operated by human or machine. Switches can be mechanical, where the physical contacts are made to open or close a circuit, or even as part of a component such as a semiconductor like a transistor. There's many different types of switches, and we even use the word button to describe a momentary switch, but it's still a switch. Like any other component, switches have operating parameters such as voltage and current limits, although it'll probably be less of an issue at the conditions we're using in hobby electronics, but it could come up in the future. Keep in mind that not all switches are made to fit into breadboards, as they may have larger terminals and they're meant for direct wiring, although you can probably jury rig them with some attached wires that do fit a breadboard. Now, we have many different types of switches, and like types with other components, they can certainly overlap. I already mentioned momentary switches where you push the switch and it opens or closes, then springs back into its default state. We have toggles, so a toggle button would be held in place when pressed, and then when it's pressed again, it'll release. Slide switches, where it slides from one position to another. Dip switches, which are essentially just slide switches, but they're in a dual inline pin package and they can be anywhere from one to, I guess, infinite, whatever you can fit. Plungers have a little rod that acts like a button that turn it on and off when you press or release it. Rotary switches, they're twisted around to different positions. They create different circuits. Limit switches, when a switch reaches a limit, basically. Float switches, which usually float in a liquid and switch at different points at the fluid level. Pressure switches, works off fluid or air pressure, switching at a specific level again. Temperature switches, same idea, but for a specific temperature level. Joystick switches, switches based on the joystick position. And electronic switches, which can include transistors, relays, and a number of other things that we'll get to in future videos. Now, one of the ways we define a switch is in terms of poles and throws. This is often misunderstood as pulls and throws because pulls and poles can sound kind of similar in English, especially depending on your accent. Poles are the number of individual circuits the switch can operate. Throws are the number of connections or outputs. So starting with single pole, single throw, this is just a simple on-off switch. When it's open, then the current doesn't flow. When it's closed, the current flows, and these switches usually just have two terminals. Um, Single pole double throw allows for the current to flow to create two different circuits. They usually come with three terminals with a common pin between the two. That common pin could be power, it could be ground, it could be a lot of things, whatever you need. You could also turn it into a single pole, single throw by just ignoring one of the terminals. Usually the other center pin, just don't connect it to anything. It's going to be an on-off switch. And then you've got double pole, single throw, which controls two different circuits at a time, with one input, one output for each, so you can turn them both on or both off. They usually have four terminals, and a typical four-terminal push button is a double pull singles throw momentary switch. You can also have double pull, double throw. These have six terminals, and you can basically make them work like a single pull, double throw, but for two independent circuits. And this number keeps going up. You've got triple pull, triple throw. I haven't really found too many quad pull or quad throw, but I'm sure they exist somewhere. You just keep increasing the terminal, and eventually it gets too cumbersome, I think, to use more. But who knows? Next, we have the concept of make before break and break before make. This is really important with switching. Now, if we have make before break, it'll create the new circuit before we break the old circuit. This may actually be necessary because you don't want any power or signal interruption. The drawback is both circuits are active for a time, and that can cause crosstalk or interference between the two, and it may lead to undesirable results. And then we have break before make, which I'm finding is a little bit more common, but where the old circuit is first broken before the new circuit is created, there's no possibility of a short circuit or crosstalk, but we do have momentary power interruption, and that may not be desirable. Now, we've already mentioned push buttons. If you get a hobby kit or pretty much anything, you're probably going to have at least one push button, but most people don't understand how they actually work. Now, technically, a push button could have any number of pulls or throws, but your typical ones are double pull, single throw, and have four terminals. They can come normally open or normally closed. This just describes their behavior when the button hasn't been pressed. I want to say they're normally, was it open? Yeah, I think I may be getting that wrong myself. Anyways, there's usually two circuit pathways, usually like pin 1 to 2 and then pin 3 to 4 when open, and then two different pathways are made when closed, like pin 1 to 3 and 2 to 4. You might also encounter dip switches in a hobby kit. It's really just a simple single pole, single throw switch in a double inline pin package, with each switch being a simple slide switch. Typically, when the switch is in the down position, the circuit's not connected. When it's in the up position, it's connected. You can, in theory, have any number of switches in a dip package, but obviously, past a certain point, they can be too cumbersome for a breadboard. It's also perfectly fine to put different switch packages together, as one switch doesn't automatically affect the other. Obviously, when you get into more complex circuitry, it may, but not in the package itself. You could combine like four dip 2s and a dip 8 to make 16 switches. All right, let's take a look at every circuit and what kind of switch options we actually have. We have a couple of things here. We've got a single pole, a single throw. We've got a single pole double throw. We've got a no button or a normally open button, got a normally closed button, and we have a relay. I mean, that is a switch, but that's going to be under electronic switches, so let's ignore that for now. All right, well, let's see what we can do here with these different switches. Let's go with the single pole, single throw, pole. Yeah, I know. Even for me, it's a problem. All right, let's see. Let's, let's put in a resistor. Slow this resistor a little bit because this is every circuit. Let's see. Here's an LED. Now, before when we did this, let's do this. There we go. Before when we did this, the light would just come on. Now we can do the switch. We can turn it on and turn it off. Turn it on, turn it off. Now, of course, keep in mind that the switch, the actual power is going through the switch in this case. All right, well, let's look at something else. Switch this with a push button, which is a normally open. All right. Keep in mind the switch is going to go right back up once we've released it. Now, effectively, this is kind of the idea with most Morse code with the switch there. Contacts were only done when you only together when you pressed it. All right, well, let's get rid of this. All right, here's a normally closed. So by default, the circuit will be we press it, it stops, press it, it stops. All right, we got one more to look at. This is a single pole double throw. Now we have no representation of the typical push button you'd find in the kits. You might be able to somehow make that work. I'm not entirely sure. All right, so this allows us still technically one circuit, but we can do two different outputs. So let's say All right, so power's flowing through there, flowing through there, there, back and forth. There's not really an off position here. I mean, we could make one that is. We could take this off and just put it to ground for wire down to ground, for example. So yeah, that's the extent of it in every circuit. All right, let's look at falstad here and what it has for switches. Now, let's see. This thing just called switch. All right, so single pole, single throw. It's push switch. So just something momentary, and they're probably about the same thing. Actually, yeah, they are the exact same thing. All right. Single pole double throw switch. All right. Double pole double throw switch. So we have something a little bit different from every circuit here. I guess actually in theory this would let us, yeah, this would let us actually create the push button action. Okay. Didn't realize that. All right, let's see. What else do we got? Make before break switch. So we've got something new. You'll see it makes and then it breaks. All right. Let's see. Anything else? This might be our only options. Still, this is more powerful than with every circuit. Or yeah. Let's see. Anything else I can see? Sometimes they put things in weird spots. Let's see. I think this is something. What was I looking at? Yeah, okay, ignore that. Let's see. All right, well, let's make a circuit with something. Turn it off, turn it on. It just works. All right, well, there's what it looks like in falstad. All right, hopefully that's explained basic switches. And just to recap, switches allow you to interrupt the flow of a current in a circuit by either opening or closing it or changing the flow to different pathways. We describe switches often in poles, which are sometimes mistakenly called pulls, and throws. And they can range from simple on-off action to operating many different circuits at once. Momentary switch push buttons are very common in kits. They usually have 4 terminals and operate as double pull, see I make the mistake too, and single throw, where the button has a default state, and when pressed, it changes the pathway of 2 circuits at once. Keep in mind that not all switches are meant for breadboard use, but you might be able to jury rig them with wires. We also have electronic switches, which we'll get into a later video. Till next time, have a good one.